So if we have 2 over 3 times 1 over 5, we simply will do 2 times 1 is 2, 3 times 5 is 15. Can we reduce that, simplify that? No, we're done. Let's look at 3 over 4 times 8 over 9. Now I could, if I were in the mood, just go straight to 3 times 8 is 24, and 4 times 6 is 36. And then you might even see you've got common factors in there, and you can cancel, and you'll wind up going, let's see, I think it'll be 2 over 3, because they each are divisible by 12. But let's just prove it. I can't cancel vertically just because there aren't any common factors between them. I'm allowed to, but there's nothing there for me to do. But I can do this diagonal. 4 divided by 4, let me get rid of that line, is 1. So I've done 4 divide 4 there. That's my action, my operation. And then 8 divide 4 is 2. But I just use the shorthand of putting that 2 up there. And good news, if I look at this diagonal, I also have common factors. And again, one of the numbers itself is a common factor. So 3 and 9 have a common factor of 3. 3 divide 3 is 1. So that 3 now becomes a 1. As long as this 9 is also, 9, thank you, is divided by 3, and that gives me 3. So lo and behold now, get rid of all this sort of mental gobbledygook. So now we've got 1 times 2 is 2, 1 times 3 is 3, and we've come up with the same answer. Now here we've got a bit of code. We've got 4 over 8. 4 eighths of can be turned into this. That'll give us 12/48. I reckon it's going to give us a quarter. This time, we're definitely going to cancel like this, up and down. You might even be able to see, you're starting to see that 4 over 8, that 4 eighths is actually half. 4 divided by 4 rather is 1. 8 divided by 4 is 2. 3 and 6, they're on top of each other, so we are allowed to cancel that way. So, common factor of 3. 3 divided by 3 is 1. 6 divided by 3 is 2. 1 times 1 is 1. 2 times 2 is 4. So 1/2 of 1/2 is 1/4. That kind of makes sense. If you took 1/2 of a picture of 1/2, you get 1/4. Now, we're going to try and find 1/3 of 21. So we write it out, and we remember the rule that 1/3 times 21 is really 21 over 1, which makes it really simple. We could either go straight to 21 over 3, which divide both of the, you can use your calculator to do 21 ABC or divide by 3 to get the number 7, or we can go back and we can cancel, which is my preference that you start practicing that. Between these two, there's a common factor of 3. 3 divided by 3 is 1. 21 divided by 3 is 7. So we end up getting 7 over 1, which we write out as a whole number, 7. 2/5 has the code word of. Of means multiply. 2/5 of 32 over 1. Wow, it looks pretty simple. You're tempted to do one of these numbers and reduce that way. But no, not allowed. We are not allowed to cancel horizontally. That's the one way we can't go. So between 2 and 5, there are no common factors, so I can't cancel there. Diagonally, I can't cancel there. And one, as a factor, when you're canceling, 1 doesn't change the outcome at all. So we don't really consider 1 a factor when we're doing this. So my only real choice is 32 times 2. I'll just confirm on my calculator that it's 64. And over 5 times 1, which is 5. Now, I don't have any common factors. 64 is divisible by 2, not 5 or 10. So I just need to figure out how many 5s will go into 64. 5 times 11 is 55. 5 times 12 is 60. Ooh. So that would be equal to 12 whole 5 over 5s, 12 5s, with 4 of those fifths remaining. So that's the simplest answer. Here we've got, I'll see if I can go a little bit faster. I might just do it up here. You should rewrite it, but can I cancel? There's no canceling I can do anywhere, so 5 times 7 is 35. 3 times 2 is 6. 6 6s make 36, so that's 1 too many. And I have 5/6 left over. I'm going to rewrite this one because this one has some prime canceling that I can see right away. I can't cancel vertically, but I certainly can cancel diagonally both ways. So 5 divided by 5 is 1. Remember, we're thinking 5 divided by 5, and then 15 divided by 5 will give us 3. Oftentimes, students will write the 5 there again, and oh, that's dangerous. Between 8 and 4, we could divide by 2, but let's go the whole way and find the highest common factor. And 4 is a factor of itself. 4 divided by 4 is 1. 8 divided by 4 is 2. 3 times 2 is 6. 1 times 1 is 1. So our answer there is simply 6. Always, always convert into mixed numbers because it's the most foolproof method. 3 times 2 is 6 plus 1 is 7. And remember, we don't have to find a common denominator, so it's actually less work. 5 times 1 is 5, and 7 over 5. You're tempted to try and cancel the 7s, but sorry, not gonna do it. Not gonna. 7 times 7 is 49. I check it with my calculator. I'm really actually going to check it because I want to make sure. And then 5 times 3 is 15. I wonder if, well, 15 is divisible by 3. I wonder if 49, 4 plus 9 equals, oh, that's 13, isn't it? So no such luck, not divisible. But I could put a bunch of 15s in there. I could divide 49 by 15, and that'll give me a rough idea. It's just more than 3. Well, that makes sense because 3 15s is 45. I know that, and I can try that on my calculator. 49 minus 5 is 4. So that gives me a remaining 4 15ths. And finally, I'll do this really quickly. 6 times 4 is 24, plus 1 is 25 fourths, times 5 times 2 is 10, plus 2 is 12 fifths. I'm multiplying, so I don't care about the common denominator, but I do want to save myself having some absolutely wacky numbers, so I'm going to cancel diagonally. So between these two, common factor of 4, 4 divided 4 is 1, 12 divided 4 is 3, and then I'm going to do my other diagonal. So between those two, 5 divided 5 is 1, 25 divided 5 is 5. 5 times 3 is 15, 1 times 1 is 1, so that whole rigmarole actually ends up being just plain old number 15.